All right, today, guys, what we're going to be taking a look at is one of these UPA-USB version 1.3 EEPROM programmers. I got one of these recently, and it fails some of the self-tests. And after a little bit of research, I figured out how to get those tests to pass, and I'm sharing that information with you guys. So with the USB cable that it comes with, or one of the other ones, it doesn't matter, and the software that it comes with, and you pull it up here, I'm just going to plug this guy in, and then you notice down here, it's blank, and then when I plug it in, it'll detect it. You should see that to indicate that you've got a good setup in terms of the drivers and the software all installed okay. Then if you go under Tools and Hardware Test, you'll get this test that pops up, and you don't need to have any kind of an adapter or an EEPROM plugged in to run this test. It's just a good thing to fire up. And so when it first comes up, it's going to go off and find the programmer. And then it's going to tell you that you need to have jumper 1 closed, and then you can press a key to start the test. So if we go back to the programmer for a second, just to reference what that means. Jumper 1 is this guy right here that I have a blue jumper on at the moment, just so it stands out easier. And all this jumper is to determine whether you're using 5 volts or 3.3 volts when you're doing the programming. And so right now with this on, it's 5. If we took it off, it would be 3.3. And just for reference, the other 2 jumpers, this guy here, is whether or not you're going to take power from the USB or from an AC adapter. So in this position, it's USB. If you move it over one, it's going to be from the USB adapter. And the last jumper over here is just whether or not you're going to be putting out 1 milliamp or 12 milliamps. And you typically want it in the 12 milliamp position, which is the position closest to the D-shell connector. All right, so we got a green light on. The red light is not lit, an LED. We got this in the 5 volt position. So J1 is closed as the test requests. Now I'm just going to press a key on the keyboard. And what happens is some of these tests pass, some of these tests fail. Typically, with the problem I'm going to be talking about today, the tests in the first pass that fail are going to be test 7. Occasionally, you'll get intermittent on test 5 or 3. So this time they passed. If I was to run this multiple times, eventually 5 would fail. But 7 is usually a consistent failure for this particular problem. To complete the test, now they want to run some 3.3 volt tests, so they'll tell you to open that J1 guy over here. And so all I'm going to do on that is I'm going to pull this little blue jumper off. You know, typically if you were going to do this legit-wise, you just kind of leave it hanging off like that. And then we'll come back on, hit a key, and the rest of the tests passed. So we got that one test failing, number 7. If we take a look at that test, though, we can see what's going on here is P1 voltage came out to 12.54 volts. And it needs to fall in this range that it's telling you, between 12.7 and 13.3. So that's why the test failed. So 12.54 might be okay with some devices. It might be a problem with some devices. The point is it's out of specification, and we want to get that test to pass. And it's not too bad to get it to pass. So let me take you over here and show you how to fix that. So I'm going to disconnect this guy. And I'm not going to show it here, but you know, another test I did, I hooked up an AC adapter. I took this jumper here and moved it over so that I'm in the AC adapter position, and I reran the test and it passed. All of them passed, and that's what clued me into what I'm going to be showing you guys here today. So I'm going to put it back to the USB position. I'm going to put it back to the 5 volt position. And then what you end up finding is this chip here on the main board is a regulator chip, and it's actually this guy right here. It's an MC34063A. This is an on-semi data sheet. It doesn't matter what it is, but this is the type of chip. And so somewhere on this board, what you're looking for this kind of problem is what's boosting up to generate 12 volts or so, right? Because you only got a 5 volt source coming in from the USB, from the PC. So it's this guy here. And so what I'm looking for here is, so what is he connected to, and what might give me a way of changing that voltage output, or is he just defective? So if I come out here, just take a simple voltmeter and set it up to do a continuity test. And then what I first found out here was I started to look for, there's a particular pin we're interested in. Now this diagram's a little bit misleading, right? Because these are not the pin numbers. So you're going to look at this kind of picture here. Here's pin 1. You've got your dot 1, 2, 3, 4, 5, 6, 7, 8. And so what we're interested in here is there's a particular pin called the comparator inverting input. And this is what's going to kind of feed into this whole circuit. So what we're looking for is that pin there, number 5, and what does he connect to? And when you go kind of probe around and follow the traces, you find out that this guy here, hold on a second, guys. Voltmeter decided it was time to go to sleep. All right, if you put this guy here and you go over here, you find out this guy connects to here. And then if you follow this guy, what I kind of saw that was obvious was this little adjustable capacitor here. And so this little adjustable capacitor here is the problem. The factory position for this, either when it got adjusted wasn't fully adjusted, or after they adjusted it, it moved in transit. And so you take a Phillips head screwdriver, and you adjust it a little bit to the left. Not much. About that much should do it. Let's hook it back up again and see what we get this time. All right. Just heard the ding. It got recognized by the software. Now we're going to rerun the test. Waiting for it to detect. It's detected. We already have jumper 1 closed. We closed it before. Let's go ahead and hit this. And now if we take a look at these tests, right, they all passed. Actually, nope, we didn't turn it enough. Hold on a second, guys. It happens. It happens when stuff's live. Take the jumper off and just finish the other test. Make sure the rest of it's good. All right, so we still have that one test that failed. We just need to twist it over just a little bit more. And you know, normally I just break the video and cut that out, but this is a short enough video. I'll just leave that in there. Disconnect the power. Let's adjust it just a little bit more to the left. Increase our voltage. Come back over here. And what we're going to do when we get this to pass for all these tests, we're going to put a little drop of something to keep that from moving, maybe a little piece of silicone. All right, let's do this now. All right, that looks good. That looks good. Jumped the gun last time. That looks good this time. So all these tests passed. Let me go take that jumper off one more time just to make sure we still have our 3.3 volt test passing. All right, all tests passed successfully. So that is the fix for this particular type of problem. So even like before, if you go back in the video where I showed it failing, it's not failing now, but if we just take a look at these tests, all these tests are measuring some sort of voltage on pin 1, right? And they're trying to fall within a certain range. And so when you see them failing, you can see how much further off you are, and you just want to turn that adjusting capacitor screw ever so slightly, just like a hair width until you get it to where it's going to pass. And then once you do that, you're set. And if you have a particular device that's sensitive to what that voltage is, this will correct it, and you won't have to worry about that. So you don't need to chuck the programmer or turn it back in, or try to get another one. You can adjust it and fix it yourself. And again, once you get it like this, I would put a little dab of something to hold that screw there so it doesn't move anymore. So when it jostles around in your tool bag or something of that nature. Anyway, if you got a comment about this or questions about that, or the data sheet, or even what's going on with what I just showed, go ahead and leave them down below. If this helped you out and you found it useful, hit that like button, and think about subscribing too if this content is useful to you. Thanks for watching.